Hello students, this video shows an application problem of Lagrange multipliers. I will be solving this example using Solver. The problem says a company production function for a particular product is pxy, so it's a function of two variables, equal 40x to the power 0.8 y to the power 0.2, where x is the number of units of labor and y is the number of units of capital required to produce pxy, units of the product. Each unit of labor costs $40 and each unit of capital costs $60. If $300,000 is budgeted for production of the product, answer these two questions. Determine how that amount, this $300,000, should be allocated to maximize production. And second, what will be the maximum production possible? So we have these two questions, and we notice that we need to maximize this function. And this is the thing that we need to see first. What is the function that we need to maximize? What variable we have? And it's clear in this problem because they tell me the function and they tell me also the variables. So we know now that this is the function pxy equal 40x to the power 0.8 y to the power 0.2, and the variables are x and y. And what is this x? Is the number of unit of labor, they tell me here. So this is the first variable we have. X is the number of unit of labor. We have another variable that is y, that is the number of unit of capital. So we have this second variable. So, and we have already the function that we need to maximize. The question is, maximize the production function pxy equal 40x to the power 0.8 y to the power 0.2. There is one constraint, and we observe here that we have 300,000 budgeted for the production of this product, and the unit of labor is $40 and the unit of capital costs $60. So we have a constraint here. The cost cannot be more than $300,000. It should be $300,000. We have $300,000 in our budget. So we see then that the cost will be our constraint. So the cost will be equal to, and I have a function for the cost. The cost is equal to $40 is the unit of labor, and we are using x unit of labor. So the cost for labor will be 40 times x, plus the cost of the capital. The capital costs $60 per unit, and we are using y unit of capital. So it will be 60 times y, the cost of capital. So this 40x plus 60y need to be equal to $300,000. So this is our constraint. So we can say here that this is a maximization problem in which we have this constraint. So this will be subject to 40x plus 60y equal to $300,000. So we have already solved the problem because we already know what is the objective function and we need to maximize, and also the constraint. Now what we need is just a tool, and the tool of course could be Excel Solver. So let's use Excel Solver to solve this problem. So we open Excel, and I have already the label of each of the cells that we are going to use. So we need to choose some cells that will be for the independent variables, in this case x and y. The objective function, that is the production, this is the thing that we want to maximize, and the constraints. In this case we have only one constraint. So I'm using A2 and B2 as the cells that will be the cells for the independent variables. A1 and B1 are just cells for the labels, just for me to remember what is everything. So here in D, I will be typing the production function. And the production function, the one that we want to maximize, that is equal 40. So let's type equal 40 times the variable x, and I know that the variable x will be this cell A2. So I click here in A2 and to the power and make it to the power 0.8. so to the power 0.8. Then I'm going to multiply, and we need to use always the multiplication sign, the start, for a multiplication in a cell. And then multiply by y. And the cell for y will be B2. So I click in B2 and B2, so this is y to the power 0.2. I press enter, and obviously because so far A2 and B2 are 0, so this multiplication is just 0. So that's the reason that Excel is giving you a 0. And now here type the constraint. And we have the constraint that is 40x, so it will be 40 A2, that is x. So I'm going to type here equal. Anytime that you're going to type a function in a cell, type equal 40 times A2 plus 60 times B2, that is y, and press enter. So again, the answer will be 0 if x and y are 0 as they are at that moment. By default, in the window of solver, you need to choose as a first thing the objective function. The objective function is production, and this is in D2. Remember, D1 is just the label. Is D2 actually the function for the production? So open solver, so go to data, you click here in data, then solver, and after you open solver, open the windows for solver. This window now have D2 already in the set objective. So I have as the objective function D2. So far I don't need to do anything. If this problem is a maximization problem, click here if you haven't selected. If no, by default, that will be there, the maximization problem. If this is a minimization problem, just choose min at that point. And by changing variables, here you are going to type the cells or choose the cells corresponding to the independent variables. So I'm going to put the cursor here, and after I put the cursor in this cell, I'm going to choose the cells for the independent variable. They are A2 and B2 at that moment, and they are selected already, so A2, B2. It's giving me also the name of this spreadsheet, that is sheet 1. With that, we have already told Excel what will be the cells for the independent variables. Good, after doing that, click here in add and add the constraint. There is only one constraint, and this constraint is here in the cell F2. So I'm going to choose this F2, so they appears here immediately, the cell F2. I need to choose the sign, and I know that the sign is equal in the constraint. You see here the constraint for x plus 60y equals. So the sign is equal. And the number here is of the constraint. It will be the number on the right of the constraint. So this is the number 300,000. So I'm going to type 300,000. And press OK. So we have the independent variables, we have the constraints, and now make sure that the variable x and y are not negative. So this is a real life problem usually, especially if the problem is about cost of number of units, it will be a positive number or minimum 0. So because they cannot be negative, so that must be selected. It's already selected by default. Use GRG nonlinear for a type of problem like this, for the Lagrange multipliers, because usually this function here are not linear, and this GRG is just the method that Excel is using for solving the problem. So Excel is not using Lagrange multiplier. He's using a numerical method that is called GRG. But they're gonna give you the solution. So press solve, and that's it. Excel spends some time, but you notice that the answer is 6,000, around 6,000. It will, because this is a numerical solution. the answer could be not exact, but it's very close to the real answer. So the answer is 6,000, and for y the answer is 8,000. We can answer now question A. Determine how that amount should be allocated. So it will be 6,000 units of x, and remember x is the number of units of labor, so it will be 6,000 units of labor. And y, it will be the number of units of capital, so y will be equal, this number is close to 1,000, so it will be 1,000, 999.99995. This number is very close to 1,000, so you can answer 1,000. And the production, it will be this number here, so it will be the production at that point will be 167,718.51 unit of production. So we can answer question A. To maximize the production, we should allocate 6,000 units of labor and 1,000 units of capital. And B, the maximum production is 167,718.51 units. That are the numbers that we saw in the Excel spreadsheet. Okay, with that I finished the explanation of this problem. I hope you have found it useful. Thank you.